Okay, so this is on antiderivatives. And the author says a function, and on this one you use an uppercase F. The function F is called an antiderivative of a function, and on this one use a lowercase f, over an interval I if the uppercase F prime of x equals the lowercase function f of x at every point of the interval I. Now basically what we've done up to this point from August till now, I've given you the function and said what's the derivative. Okay, now we're going to start working. I'm going to give you the derivative and you got to work your way back to find the original function. Okay, so consider an uppercase f of x equals x squared plus 4. What's the derivative of that? X. Okay, consider uppercase f of x is x squared minus 5. What's the derivative of that? 2x. Okay, if I give you uppercase f of x is x squared plus 1/4. What's the derivative of that? 2x. Okay. Did that constant have any effect on the derivative? No. Okay. So uppercase f of x plus, we're going to use c for the constant, is the family of functions uppercase f of x plus c is the family of functions called the general antiderivatives It's called the general antiderivatives, and C is the arbitrary constant. So if I gave you the f prime of x was 2x, you can't tell me it's x squared plus 4, but you could tell me it was x squared plus c, some constant. Okay, I need you to make 3 columns, and we're going to do quite a few of these. Okay, and the first column is the function, and it's lowercase f of x equals the uppercase f prime of x. In the middle, I want the general antiderivative. And then in the last column, it's kind of our check column. Okay. So when we look at the ones over here in this first column, what I'm now actually giving you is the derivative. Okay? So if I said this was 3x squared, to find the antiderivative, before when we found the derivative, we took the exponent times the number in front, we depressed it by 1. Now we're going to find the antiderivative. The antiderivative is, okay, watch for a minute. Take the exponent they give you, add 1 to the exponent, divide by the new exponent. And then it's the general antiderivative. All of these are going to have a plus c. Okay? Then reduce it. Okay, so if we simplified, the 3's would divide out, and we'd have x cubed plus c. Okay, now take the derivative of, if I just said take the derivative of x cubed with respect to x, shortcut would take that number times the number in front, depress that exponent by 1. Okay? Okay? So this is what we were trying to find, that general antiderivative. Okay? Everybody okay with that? Okay, if I give you 1 over x squared, 1 divided by x squared, instead of we're not ready for anything with backwards quotient rule or anything like that. So rewrite this as x to the negative 2 power. Okay, now on the polynomial ones, the rule is add 1 to the exponent. So if you add 1 to that, you get x to the negative 1, divide by the new exponent, and then on all of these general, we can't tell what the constant was, so it's just plus c. And you can simplify it to negative x to the negative 1 plus c. Okay? So if we want to check, we just take the derivative of a negative x to the negative 1 with respect to x. Take that exponent times the number in front, would just be positive 1. Okay, depress the exponent by 1, so it'd be x to the negative 2. And did we get what we started with? Yeah. Okay. The antiderivative that we were looking for is that part. Okay. So on the polynomials, you add 1 to the exponent, divide by the new exponent. Okay, that's my third time for saying it. Okay. You add 1 to the exponent, divide by the new exponent. Okay. You add 1 to the exponent, divide by the new exponent. That's on the general polynomial equations or functions. Okay, third example. Say I have 1 divided by 2 radical x. Again, rewrite this. Radical x is actually x to what power? X to the 1/2 power. Now, if I move that up, it does not move the 2 up. Okay, it leaves 1/2. It moves this up, and it would be x to the negative 1/2 power. Okay, so you simplify it first. Okay, and then we'd still have the 1/2. Add 1 to that exponent would be x to the 1/2. Divide by the new exponent, divide by 1/2, and then plus c. Okay, the 1/2s divide out. 1/2 divided by 1/2. These are going to reduce. Okay, so you're just down to x to the 1/2 power plus c. And if you check it, the derivative of x to the 1/2 with respect to x. So you'd multiply 1/2 times the number in front, and you would depress that exponent by 1. Okay, and that is the same as 1/2. If you move that down, 1 over x to the 1/2, and that's the same as what we started with. Okay. The little error that occurs is right here. People take the 2 up. That 2 stays. That radical is just with the x. Okay. So we still had, or we added 1 to the exponent. To find that general, and our answer is actually, this is the general antiderivative. We added 1 to the exponent, we divided by the new exponent. Okay, so if I give you a polynomial function 10x minus x squared plus 2x to the 0, find the general antiderivative. So for each term, this is like x to the first. So for each term, you're going to add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent. If that was just a 2 there, it's like 2x to the 0. So you add 1 to the exponent, divide by the new exponent, and every one of these is going to have a plus c on it. Okay? So you can reduce on that one. That one actually equals 5x to the second minus 1/3 x cubed plus 2x plus c. Okay, and then if I took the derivative of that, and I'm writing this in the derivative, but I could use y prime, or I could use, I just didn't on this one. Oops, left out the x. Right. So if I take the derivative of my antiderivative, I would end up with 10x to the first minus, take 1/3 of 3 would be 1x squared plus 2. And 2 is the same as 2x to the 0. Okay? Everybody getting the idea? Those are the polynomial ones. Now, this is the rule. Okay? X to the n power. Okay, I've said it about 5 times so far. If that's your derivative, to find the antiderivative, we add 1 to the exponent, so that'd be n plus 1, divide by the new exponent, and then plus c. So that's the general rule, okay, for a monomial or polynomial. Okay. Okay. Add 1 to the exponent, divide by the new exponent, and then plus c. So this is the general antiderivative. Okay. Okay. Now those are polynomials. Okay. Now we go into the trig ones. Okay. Before we get into the trig ones, I want to go back and review for a minute. Okay. We're still going to use the 3 columns. Okay, but I want you to do a little bit of review. Actually, you can do it by looking at your card, but it's probably good to have it on the notes too. Okay. Okay. You need to go back and recall. This goes way back to page 226 when we were doing the chain rule with trig functions. Okay, we figured the derivatives, okay, and today we're going to go backwards. So you need to go back and review, okay, the derivative of sine of u, and that u represented a quantity, okay, with respect to x. Derivative of sine was cosine. Cosine of u, u is the angle, okay, and then it was times the derivative of the angle. Okay, that was one formula. That was the one for sine. Okay. Okay, we also had one for cosine. Derivative of cosine of u with respect to x. Derivative of cosine was negative sine of u. U was the angle. And then times the derivative of the angle with respect to x. So this was the one for cosine. So you have to kind of keep these in mind because we're going to go backwards now. Okay. You ought to look on your cards and find those on your cards. Where are they on your cards? Because we're going to be using them backwards. Okay. Okay, so on number 6 on this one, I'm still looking at the 3 columns. Okay. On this one, if I gave you the derivative was sine of, and I'm going to do this in general, like that might be sine of 5x, sine of 10x, okay? Okay, so we're actually looking right here. I'm giving you the derivative, but did I give you a negative sign? No, I gave you sine. So what's the antiderivative going to be? Negative. Okay, so it's negative cosine of kx divided by k, okay, and then plus some constant. So an example, let's say I put a number in there. Let's say I put in sine of, say the derivative was 5x. So the antiderivative would be negative cosine of 5x divided by 5 plus c. And if you wanted to write it negative 1/5 cosine of the angle 5x plus c. This is the antiderivative, okay, right there. And you could check it. If you took the derivative of that, you'd leave the negative 1/5. What's the derivative of cosine? Negative sign. So you'd have a negative times a negative, which brings you back to a positive. Okay. Okay. Everybody okay on that one? Let's go through cosine. What if cosine of kx? Okay, so that's the derivative. So look, you're looking right here. I'm giving you the derivative. What's the antiderivative? Sine. Okay, so this is sine of kx divided by k plus c. Because if I actually took the derivative of the kx, it's just going to be k. Or 1 over k, sorry, 1 over k. Okay, so if I did, let's put a coefficient out front. Say I give you 6, oh no, I didn't get, well, I'll make up one. Let's say I give you, erase that a minute, that's on the next example. Let's say I just give you a cosine of 7x. So then it's going to be sine of 7x divided by 7 plus c, and that's the same as 1/7 sine of 7x. 7x is the angle plus c. So this is the antiderivative. Okay. 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 Now let's put a coefficient out front. Let's say I give you 6 sine of 3x. Say that's the derivative. Okay. Okay. Now you have to go, okay, if that's the derivative, go back up here. Okay, I'm giving you this, but am I giving you this? No. So what's the antiderivative? Negative cosine. Okay, so the 6 stays the same, but it's negative 6 cosine of 3x divided by k divided by 3 plus c. So simplify it would be negative. That 3 divides into coefficient in front. It does not change the angle. And then plus c. And you can check it. If you took the derivative of negative 2 cosine of 3x, with respect to x. The derivative stays the same. So, I mean, the coefficient stays the same, -2. What's the derivative of cosine of 3x? So you go back up here. What's the derivative of cosine? Negative sine. So it would be negative. So there would be a negative sine, and it would be negative sine of 3x. And then it's times the derivative of that angle. The derivative of the angle would be 3. So then you multiply. Negative times a negative is a positive. 2 times 3 would be 6 sine of 3x. Okay. Okay, that's a little bit on examples. I want to go through one differential equation. Okay. An equation like the derivative of y with respect to x equals f of x that has a derivative in it is called a differential equation. A lot of times in college you go through Calc 1, Calc 2, Calc 3, and the last fourth semester is series and differential equations. So they're working with equations that have derivatives in them. Okay? Now, let's look at an example. Say they ask you to find the curve. At the beginning of the year, I gave you the curve and said find the derivative. Okay, now they're going backwards. Find the curve whose slope at the point xy is 3x squared. So when they're giving you the slope, they're giving you the first derivative. Okay? If the curve is required to pass through the ordered pair 1, -1. So when they're giving you that ordered pair, they're giving you an x and they're giving you a y. Okay? So here's how you start this one. These are called initial value problems too. The derivative of y with respect to x. They're giving you the derivative is 3x squared. Okay, now you take the antiderivative. The antiderivative of the left side is just the y. Take the antiderivative of the right side. So you add 1 to the exponent, divide by the new exponent, and then plus c. Every time you do that antiderivative, you're doing plus c. Okay, you can reduce the 3's. These will divide out. Okay, and you're at y equals x cubed plus c. Now the trick is find the c. Okay, so take these two values and sub in. X is 1, y is -1. Okay, so 1 cubed is just 1. Subtract 1. So c equals -2. Now you go back to this equation and substitute in the c, because you know what the c is. So y equals x cubed minus 2. Okay, and that's your curve. Now, if I went back to what we were doing in September, and if I said, okay, here's your curve, find the first derivative, what would your derivative be? Y prime would equal 3x squared, right? And that's what they gave us, okay, up here. Okay? Okay?